Alright. Let's start with something like this, where we've got points A and B. A is at 4, 2, B is at -3, -5. Let's do midpoint first. Okay? I'm not going to give you the formula right off the bat. Right. How do we find a point that's right in between two other points?
Add 4 divided by 2.
Yeah, we want.
Is it that one thing where it's like y2 so is that thing? Or am I thinking of something completely different?
That's slope. y2 minus
okay.
y1 over x2 minus x1. That's slope. So, Alex, say what you said again.
Add up the points divided by 2.
Right? If we want something right in the middle, that's an average, right? A midpoint is an average of 2 points. So if I want the midpoint, I'm going to take and add the two x coordinates together, divide that by 2. I want the average of those coordinates. I'm going to do the same thing for the y coordinates then. Okay? So our formula, okay, is just the average. And our formula is x1 plus x2 over 2. The x coordinate, y1 plus y2 over 2 for the y coordinate. So if I take those two numbers here, my x's are -3 and 4. Bless you. And my y's are 2 and -5. So my midpoint would be 1/2 and -3/2, or 0.5 and -1.5. Most of the time, I'll ask you to leave things in fraction form. So you can leave this as 1/2 -3/2. So all the midpoint formula is finding the average between 2 points. Questions? All right, find me the midpoint between -7, 4, and 13, 2. What do we get?
3, 3.
Yeah. I think we should get 3, 3. Okay, if I just take the average, so -7 plus 13 is 6, divided by 2 is 3. 4 plus 2 is 6, divided by 2 is 3. So the midpoint is 3, 3. What if I gave you points like this? How would we find the midpoint between those points? It's the same process. Just because there's variables in there should not throw you off. It's the exact same process.
So that's I'm just going to
Trigonometry, calculus, derivatives. 4.
English 4.
Wait, why did you not just add the points? Dude, I'm so anxious if you don't add that, bro. Dude, if you don't add that to one side of the road, we're in like 1 day. Oh, wait, we're doing work.
Did we get b plus q over 2 and 11 plus x over 2 or x plus 11? Okay. So even if we have variables in there, it's still the same process. Questions on midpoints? All right. Let's talk about distance then. Let's go back to this same example we have on the coordinate plane here. And let's figure out how to find the distance between points A and B. So I don't expect you to have the distance formula memorized. I want you to understand how to get it, where it comes from. Okay, so take a few minutes here and think about how we would find the distance between two coordinate points.
Strawberry one.
So have you used years of automotive? Dude, since 8th grade, Mr. Freaky's class, bro. Dude, Sam, I don't think you want the rest of the YouTube throw it. They're right in the back. Alright, what's this one? They're all here.
I don't know, it hit me.
Was it like open or how did it Oh,
I should stop class in 10
Yeah,
minutes.
it's
I
a
will
tally.
Yeah.
All right. What do we think? How do we find the distance between 2 points?
D parentheses.
Don't read me the formula. I don't want the formula. I want an explanation of how this is done. Just like 1, 2, 3, 4, 5, 6.
Yeah.
6.
Basically, you have a square root.
Add what up?
The
Dude, you just count the distance.
What we're doing is Pythagorean theorem. Right? Distance formula is Pythagorean theorem. I'm going to make a right triangle and find the length of the hypotenuse. Okay? That's all distance formula is. It's Pythagorean theorem. Alright? So, what the distance formula, okay, and I'll write the distance formula up here. Okay, the distance formula is find the difference in the x's, square it, find the difference in the y's, square it, and then take the square root. Okay? The difference in the x coordinates. Okay? Well, my x's are -3 and 4. What's the difference there? 7. Right? So my right triangle has a side length of 7 here. What's the difference in my y's? 2 and -5? 7. Okay? So what I'm doing, finding this distance, I'm using the Pythagorean theorem. So I'm going to say 7 squared plus 7 squared equals AB squared. Okay. 7 squared is 49, plus 49 equals AB squared. This is 98. Then take the square root of both sides. So, does the square root of 98 simplify? We want to think about exact answers here.
I'm gonna go.
Yeah, we just added 49 together, right? So hopefully we can recognize that this is 49 and 2. The square root of 49 is 7. Okay. So first, do we all feel comfortable simplifying radicals? Okay. Second, this is the distance formula. Okay. Let's actually get to this point though. Okay, with what we just did. If instead of putting numbers here, we erase these and put x1, y1, and x2, y2. Okay, and then we can call our hypotenuse d for distance. So to actually derive this formula, right, if I'm thinking about Pythagorean theorem, right, well, if I want the length of this side, that's the difference between the x-coordinates. So we could do x1 minus x2 or x2 minus x1. It doesn't really matter. Right? So we'll say that this is x2 minus x1. And then this side is the difference in the y-coordinates. Right? So y2, oops, y1. y2 minus y1. So to set up the Pythagorean theorem now, to solve for d, I'm just going to say, well, one side squared, so x2 minus x1 is the length of this side squared, plus this side squared, so y2 minus y1 squared equals this side, the distance squared. Then to solve for d, all I do is take the square root of both sides. That's where the distance formula comes from. Right? Personally, I think it's easier to just set up a right triangle from a graph than plug a bunch of numbers into a formula. Right? That's up to you, though. Okay? I don't even like to have this memorized. I just like to set up a right triangle. If you want to memorize that and plug numbers in, that's okay. Right? But I will leave that up to you. Questions at all on distance, right triangles? Feel pretty good? All right. Let's see. How about if I ask you to find the distance between these 2 points? Let's use different variables. Let's say A and B instead of X and Y. Yeah. Well, A7 and 3 negative B. That's a B, not a 6. Find me the distance between those 2 points. A7 and 3 negative B. September 13th.
Yeah.
We're selling programs.
That's exciting.
Oh.
I would think, do I?
It's some. Down on your calendar, 13th.
Hey, boss. Dude, is that a freaking Tuesday?
Football games are usually on Fridays.
Exactly. But now,
Let's all make fun of Samuel. Wait, Bill, how do you, can either one be x1, y1, or where are you so confused? Okay, I thought there was a way to determine that. I'm an idiot.
It's not 6 or 7. It's a B.
It just matters that you're consistent, right?
Cool.
Yes.
Yeah.
That's a big one.
I mean, yeah.
Yeah, well, it just, it's just that I have to handwriting.
Did we get something like this? Okay, there's not really much we can do after that since we've got variables in both pieces. Like you've got the 7 plus b first.
No,
Or the,
I had a few ones.
oh, hello? Yep.
I have 6.
Not a game you want to play.
So, no, it does not matter. As long as you then have negative b minus 7 over here. Yep. Yeah, so that would also be a correct answer. Right? If we've got 3 minus a squared plus negative b minus 7 squared. Okay? Because it does not matter if I made this one my x1, y1, or this one my x1, y1. You'll get the same answer either way. These are equivalent statements. Questions on distance formula at all? Oh, are you saying can we just make this a minus 3 plus 7 plus b? No. So if I just cancel everything out, this should be 11, right? Yeah. Well, is that 11? Square root of. Okay,
I don't even know if you got it. I don't even know.
Yeah. How did you pass the
So to answer Alex's question for everybody, whenever we have addition or subtraction under a radical, we cannot just cancel things out. Whenever we have multiplication or division, we can, but if we have addition or subtraction, we cannot. Okay. Other questions?
That's why